In this video, we're going to be doing the calculations for our cables. So what do we have here? Here inside we have the plan, then the dotted lines that you see. This is the roof pitch or how the roof goes. Then here where we have this triangle that you see, that's where we have our gables. So normally the definition of a gable is that it's the triangular section of the wall at the end of a pitched roof. So yeah, if you go on this modern house, you would only see, you could see this triangular section on each and every house. So that means that it's your thing, your gable. So on this drawing, I think the only dimension that we need now, since we're going to be working with this one, is the dimension which is going to be in to in, which is actually drawn on the actual plan. But since I have a small space, I'm just gonna include it for you guys. That okay, from here to here they had a spacing of how much? I think it's 4953. Let me just confirm. It's 4945. Okay, they had a spacing of 4945. So since we have a spacing of 4945, then you can see how the roof is going to move. It's going to move exactly at the straight of those corners of our wall. You see? So yeah, it's more or less going to be something like this, which I tried to draw to at least illustrate further. So we have the building, then we have the roof, you see. So now one other thing that you have to note is that if you are not given the projections, what are projections? Projections are normally this distance, this shorter, smaller distance here. On your drawings, you can use the width of the wall. So in this drawing, our width that we had, it was 308. So this wall is 308. As you can see, there's a roofing. It's moving in this way and in this way. It's crossing this wall here and also this wall here. So how we're going to do it is that on this dimension that we have, we're going to be adding the 380 on the right and the 380 on the left, since we do not have any given projection. So now we're going to work out the new entire length. That what do we have? We have our 380 plus your 4945 plus 380, then this gives us 5705. It's your 5705 millimeter, you see. So now we can just say, if we're looking at this portion, the triangular part at the top, we can draw it and say we have something that looks like this. Then here we have our 5705 millimeter, you see. So now also to note, in SA, most of our roof pitches are around 20 to 25. So in this one, we're going to use a roof pitch of 20 degrees. Roof pitch meaning here we can have 20 and here we can have 20 that side. So we have that 20 degrees here and also 20 degrees there. Then we know in the middle here we'll have that working height. So you know, since we have 5704, if we have one half of this, we can just say we have something that looks like this, because now we have to work out this edge. We'll say okay, here we still have that 20 degrees, but now what will be this? It will be half of 5705, which is going to give you your 2853. You're going to get your 2853 millimeter. Then how do you work your H? You know, okay, in maths we have what? We have your soccer thrower, where we want opposite of this angle, which is our H. It means now we're going to be using this tan, you see. So how we're gonna go about doing that? We're gonna say we have tan of 20 degrees is equals to our H over 2853. Therefore now this implies that our H would be given as 1030, yeah, it's 1038 millimeter. It's given as 1038 millimeter. So now we've worked the height going up. So now let's see. So now we come to the crucial part. So remember, as I said, I've tried to at least maybe throw an example. This is not related to this, but I've tried to throw a detailed one so that I can be able to explain this. And this one, don't never mind the thickness. This is basically this timber here, but I've at least maybe tried to make it bigger so that you can be able to understand this problem. But so basically you're going to be having something which is similar like this. Then now when we are doing our gables, we normally at the top, when we are doing this timber that's here that you would see, we have about these 2 bricks that you would see here. So you normally have your 2 bricks there. Also on this side you would going to have your 2 bricks. Then remember our plank is just gonna be somewhere there. No, I'm going to like this. Our plank is somewhere there. Then here you would have something like your roof. So basically when we're doing this, we're trying to at least cover what? We're trying to cover this spacing that you see, which is here, and also the spacing that you see here when this thing is gonna touch. So if you can see it, it's here and also here. It's some sort of like a closing, because if you now you look at this wall, you have something like this. So now we are closing a smaller portion, like a smaller portion like that, this side and also on the other side. So how are we going to work that one out? We're gonna say, okay, we normally have that 2 courses within that space or at the top. So we have 2 courses. So one course is what? One course is 85 millimeter. This 85 millimeter is made up of 75 millimeter for the brick, and also 10 millimeter for the mortar space, just so that you know. So since we have 2 of this, we can just say we have 2 times 85, then this is going to give us 170 millimeter. So this is for this, but now we still have to calculate that smaller triangle. So how are we going to get that beam fill height? So we just gonna call this the beam fill height, the small height. The beam fill height, we're just gonna say we have this roof pitch that we set it at 20 degrees. So now we can just say, in order to work that small portion, we have this 170, then we multiply it by the tan of 20, then this will roughly give us how much. Oh yeah, it will roughly give us 62 millimeter. So now we can just work the overall height from there to there. It's just going to be the 2 courses plus the small height. So this is basically the beam. So we're going to get how much we have. This 62 plus the 170 for the wall. Then this gives us how much we're getting. 232. We're getting 232. So far I just hope we're still together, because I'm about to I'm about to clean this board and continue with the calculation. Then I think I still have some small space at the bottom to just draw the things we have been calculating. Okay, so let's just say now we have something that looks like this. So far, what did we calculate? We did calculate that be this 1. Let me just highlight it like this. Then this one at the top, I'm just gonna do it like this. It's not concrete, but I'm just gonna do it. So it means now we have 2 areas that we're going to be working with. We have area 1 and we have area 2. You see? So when you're gonna go to your measuring paper, how are you going to do it? When you're area 1, remember this distance or the height from here to here is this 232. So this one from here to here is this 232. So we've worked it out. So it will be from here to there. It's this 232. Then the distance from here to here, we've worked it out. It was 5705. So we can go to a measuring paper. Remember, when we are going to a measuring paper, we start with the length, then we go to our breadth. That's basically how we do our area. So what would be the length? Our length will say it's our 5.71. Then the breadth is going to be 0.23. Remember, I'm measuring in meters, so it's 232 divided by 1000. Then it's going to give us 0.23 meter. So this is for what? This is for area 1. So now we move to area 2. Area 2, how do we measure the area of this? Area of this, it's half of base times height. The height we did calculated, it's at the top, it's here. Then the base is what? It's 5705. So how are we going to write it? We're going to say we have half, then our base is 5.71, then our height is going to be 1.04. You see? Then this one will just say it was for area 2. You see, this is exactly, even if you're going to do your painting, you're going to be painting on this region. So basically this is everything when it comes to your beam filling. So yeah, you just have to do it like this. Calculate this as area 1 and also as area 2. So yeah, as easy as that.